Welcome to today's lesson on section 14.2, which is titled Translate and Reflect Trigonometric Graphs. So we talked about how to graph basic sine, cosine, tangent during block number 2 this week. And so on Monday we'll be doing some practice problems on this stuff. But also it's important that we talk about how to translate and reflect these. For example, when there is an actual h and k value you have to take into consideration. So you see that we have y equals a sine b parentheses x minus h plus k, y equals the cosine tangent. There's actually a strategy you want to use for graphing sine and cosine graphs that have h and k. Here's the strategy. You want to set b x minus h equal to 0 and 2 pi to establish new starting and ending points. By doing that, what it allows you to do is allows you to take care of the horizontal shift and the horizontal stretch. So this takes care of the horizontal shift from h and the horizontal stretch or change in period with b. Also, want to find the new midline if there is a k value. And then finally, plot your 5 points like we usually do. And sorry for if you hear any noise, there's actually a helicopter flying over us right now. Okay, so hopefully you can hear me. So plot your 5 points like we usually do. So let's actually do the examples that deal with sine and cosine, and we'll see if there's time to do the tangent graph, because I do have to head to the Giants game in a half hour. So let's look at example 1. And by the way, if we don't have time to do the tangent graph, we could always obviously do it on Monday. Example 1, graph y equals 2 sine 4x plus 3. So the strategy here again is I'm going to let 4x equal 0 and let 4x equal 2 pi. So this will help take care of the change in period and if there's any horizontal shift. So of course here x equals 0 and here x equals pi over 2. So what that means is that I'm going to start at 0, I'm going to end at pi over 2. Also that means that the points in the middle will be pi over 4, that'll be pi over 8, and 3 pi over 8 because we need 4 equal intervals. The midline will be at y equals 3. The amplitude is going to be 2. And there's no reflection, since A is positive. So that's 1, 2, 3, 4, 5. So we obviously want to start at the midline for sine, because remember sine looks like this, the most basic sine function. So I'm going to start at 0, 3, plus if we were to plug in 0, you would see that sine of 4 times 0 will be sine of 0, which is 0, 2 times 0 is 0, 0 plus 3 is 3. You got to go up to 2, back to the midline, then go down 2 units, and then finally back to the midline. So your graph looks like this. So without having to make a table, you can do this very simply by knowing the new starting and ending points, realizing the midline is 3, so you got to shift it up 3, and then taking the amplitude into account when you're drawing the curve, because you have to rise up 2 above the midline and down 2 below the midline. And if you actually were to plot these points, you would see that you would get the same thing. Okay, let's do the same thing for cosine. So start and end. 2x minus 3 pi, set that equals 0. 2x minus 3 pi, set it equal to 2 pi. So if you solve it, x minus 3 pi equals 0, x equals 3 pi, x minus 3 pi equals pi, x equals 4 pi. And that makes sense because if p is 2, the period is 2 pi over 2 or pi. So we expect the difference between start and end to be pi units. So let's say that's 3 pi. Let's say that's 4 pi. Chop it up like we do here. That will be 7 pi over 2. Because that's 3.5. This one's going to be a little tricky to figure out. In this case here, don't worry about those tick marks. Simply because that's just a little bit too much to think about and too much arithmetic you have to do. Okay. So midline is still the x-axis. Amplitude is 5. So here's 5, and here's negative 5. And remember, cosine always starts at its peak. That's the general curve for y equals cosine x. But of course, because it got shifted over 3 pi to the right, because our h here is 3 pi, so that's where we start. Then we go to the middle. Then we go here, back to the middle, and back up top. And that right there would be your cosine graph. We could probably do the tangent really quick. The strategy for tangent would be y equals, oops, sorry, give you an example. The strategy is to shift the center of the graph from 0, 0 to h comma k. And then determine the asymptotes based on the period. So in this case, we'll focus on the b value. So if we look over here, negative 3 tan x plus 5, this is the general curve for a tangent, in case you're curious, if you forgot. So in this case, h is 0 and k is 5. So instead of the center being at 0, 0, the center of the graph will be at 0, 5. So 1, 2, 3, 4, 5. B is 1, so period is still pi. So what that means is your asymptotes won't change. Of course, if our period was larger, I'd clearly move the asymptotes out wider, or if the period is smaller, then I move the asymptotes in closer, depending on what we have. And we'll see some examples of that on Monday. I don't want to give you too hard of a problem for the weekend to look at. Then finally, for these values in the middle, negative pi over 4 and pi over 4, if you think about it, you have to reflect about x-axis and stretch by a factor of 3. So instead of having the graph increase from left to right, it's going to decrease. Here's a 5, here's 8, and here's going to be 2. So you're actually going to start over here, because you have to go 3 higher instead of going 1 up and 1 down. You got to stretch by a factor of 3, and of course it has to be decreasing. And then finally, we go down to pi over 4 comma 2. So that's how the graph would look. A little tricky, but that's what we have. So, looks like we're all set. Hope you guys have a great weekend and you enjoy the conj that went on today, and I will see you guys on Monday. Goodbye.